Okay, let us solve this problem on organic chemistry. This problem appeared in JEE Advanced 2017 paper. And the problem is we are given 4 compounds undergoing substitution nucleophilic reaction. And with respect to that we are given 4 statements and we need to figure out the correct statement. There can be more than one answer possible for this problem. So the first statement is compound 1 and 3 shows SN1 mechanism. Option B is compound 4 undergoes inversion configuration. Third one is compound 1 and 2 follow SN2 mechanism and the order of reactivity for 1, 3 and 4 is greatest, then come 1, then come 3. So let us try to analyze these 4 statements and find the answer to this problem. So as per problem we can see that 1 and 3 can follow SN1 mechanism. So let us examine the compounds 1 and 3. So this is our compound 1. Here we are having Br. So if it performs SN1, so this halogen will get removed and a carbocation will get formed here. And this carbocation is benzyl carbocation, which is quite stable. So definitely it can undergo SN1 mechanism. There is no doubt for that. Now the second one, that is the compound 3. This is CH3, again CH3. Here is again positive charge. So if it forms carbocation by SN1 mechanism, this carbocation is tertiary carbocation, which is very stable, and it will definitely only undergo SN1 reaction. Because SN2 is not possible because steric hindrance is quite very high here. So we do not expect SN2 to follow here. So only SN1 is possible for this compound. And also here also SN1 is, more amount of SN1 is can we expect here also. So alternative A is absolutely correct. Next come alternative B, in which compound 4 shows inversion of configuration. Now the compound 4, if we look it carefully, we can see that here it is bromine, here it is CH3. Now if we remove this bromine atom and assume that it undergoes by carbocation mechanism or SN1 mechanism, there is a positive charge formed, which is very much stable because it is a 2 degree as well as benzyl carbocation. So 80% or 90% of times it will undergo SN1 mechanism, and in SN1 mechanism both inversion and retention product is found, which are 50-50. So yeah, it can undergo inversion in configuration. That is also correct. If it undergoes by SN2 mechanism, which is quite less, then also it will undergo inversion of configuration. But most of the time, since it is undergoing SN1 mechanism, and in SN1 mechanism we expect both inversion and retention product. So yeah, this can show both inversion of configuration. So B is also correct. Now in C, that is 1 and 2 follow SN2 mechanism. So if we see 1 and 2, we can say that yeah, that can follow SN1 mechanism. It can follow, but there is no hesitation that it will not follow SN2 mechanism. There is no support of evidence that it can't follow SN1. There is no steric hindrance. Also steric hindrance is quite low in both these cases. Also the carbocation is stable, so we can say that it can undergo SN1 as well as SN2. So it can undergo SN1. So C is also correct, and it can also undergo SN2, but definitely third will not be going to undertake SN2 mechanism because it is sterically so much hindered. And last one is order of reactivity for 1, 3 and 4 is 4 greater than 1 greater than 3, but the path is not mentioned in the alternative D. So we are not in a position to decide this order, because for order to be decided we must need a path. So here path is not defined, so D can't be correct answer. Nothing is specified about alternative D. So these three are the correct answer to this problem.